The final subject that we're going to talk about is the correlation coefficient. The correlation is a useful number when you want to understand the relationship between two continuous variables. Okay, so like I said, these pivot tables, they're useful for categorical variables. But what if you want to understand the relationship between two continuous variables? For example, I'm going to go over here to this wage survey data. Okay, so we're actually going to dispense with our class survey for a moment. Let's take a look at this wage survey data. Okay, and so you can see this is, as the name suggests, a survey of people's wages. Okay, and here we have two variables. We have IQ and we have the wage. So I'm interested in, say I was interested in understanding what the relationship is between somebody's IQ and their wage. Okay, the IQ test is supposed to measure your intelligence, right? So maybe people who are smarter make a higher wage. That would be a reasonable hypothesis. Okay, so let's see if there's any evidence of that. So what I'm going to do is I'm going to take this IQ column, okay, and copy it. And then I'm going to go over here to my scatter. We haven't used this sheet yet. I'm going to go over to this sheet that's titled scatter, and I'm going to copy that variable into the first column here, column C. And then I'm going to go back there, and then I'm going to take my other variable, wage, and I'm going to copy it into this next column, column D. Okay? And so first of all, have a look at the scatter plot. You put that data in, and this scatter plot is going to be updated. Okay? And so it's going to draw whatever variable you put in column C along the x-axis and whatever variable you put in column D along the vertical axis. Okay? And so you can see here that, okay, so we have, it looks like people's IQs in this data set range from 60 to 140. Okay, and their wages, okay, these are monthly wages, okay, range from, close to zero all the way up to more than $3,000 a month. Okay, and okay, so the question is, what is the relationship between IQ and wage? Well, if you were to fit a trend line through this data, which I've done here, you can see this light blue line, you can see that that trend line has a positive slope. And overall, you can see that in general, I mean, it's a very noisy relationship, okay? But in general, as a person's IQ gets higher, it looks like their wage on average also tends to get higher. Okay, if you were to look at the overall direction of this cloud of dots, you would say that maybe this cloud of dots has sort of an upward sloping shape. Okay. Now, this scatter plot, okay, is associated with a specific number known as the correlation coefficient. Okay. And the correlation coefficient of this data here is 0.3. Okay. Now, the higher this correlation coefficient is, the stronger the evidence that there's a positive relationship between these two variables, between IQ and wage. Okay. So let me give you guys a few more examples of that. Okay. If you haven't seen this before, it may be a little bit confusing. Let me give you guys a few more examples. Okay. So first, let's have a look at this website, guessthecorrelation.com. Okay. So I'm going to say new game. Please enter a username. I don't know. What do you want to enter here? Let's just say Joe Mama. Okay. And what username already exists? All right. Let's Zhao He 1 2 3 4. All right. Okay. So you can see, okay, what I'm being shown here is a scatter plot, okay, much like the scatter plot that we had in our own data. And I'm simply asked to guess the correlation, okay? So now I can tell you a couple of things. First of all, it doesn't have anything to do with the slope of the line, okay? So it's not as if the relationship is steeper. It's going to give me a higher, correlation coefficient. What it's all about is how well the dots actually line up in a line. Okay, so if the dots are just sort of like a big cloud, they don't really obey much of a line at all, the correlation is going to be lower. And if the dots are like all falling on a single line, the correlation is going to be high. So for this one, I don't know. I'm going to guess 0.73. Okay, let's see if I was right. Okay, so it looks like the true value, this R is another, often this correlation coefficient is denoted R. Okay, so it looks like I was pretty close. So the true correlation was 0.69. Okay. Okay, so let me try again. I'm going to click next. Okay, wow, look at this. So you can see this is an example where literally all the dots line up on a perfect line. Okay, so this is going to have a correlation of 1. So let me guess that. Okay, yeah, it looks like I was right. Correlation of 1. Okay, next. Okay, now, you can see this is kind of in between the first and the last case, right? This is, these dots are pretty much lining up on a line. So I'm going to say that this has a correlation of 0.92. Okay, so it looks like it had a correlation of 0.95. Okay, now this one, have a look at this one. This is like all over the place. Doesn't show much evidence of a line at all. This probably has a correlation of close to 0. Okay. Actually, I was a little off. It has a correlation of 0.24. Okay, but close to 0. Okay, now I want to show you guys one with a negative correlation. Okay, correlation can be negative as well. So let me just fill in some random values here and see if it ever gives me one with a negative correlation. Interesting. It seems like it doesn't really ever give you one with a negative correlation. Okay. Okay, that's kind of a shame. That's a limitation of this game. Okay. You can have a negative correlation. Okay. So let me actually show you some examples of that. Have a look at this slide here. Okay. So you can see this cloud of dots right here, this scatter plot has a correlation of 0.8. But if it were to go downhill instead of uphill, okay, then the correlation would be negative 0.8. Okay, so same thing. This cloud of dots has a correlation of 0.4. But if we had the same thing, but instead the relationship had a negative slope, then the correlation would be minus 0.4. Okay, and it's sort of like it's like a sudden change. Okay, so have a look at these scatter plots down here. So like I said, if all the points are on a line, then the correlation is going to be 1. So this has a correlation of 1. This has a correlation of 1. This has a correlation of 1. But then the minute that line starts to have a negative slope, the correlation becomes negative 1. Okay? So it doesn't become like bigger or smaller depending on the slope, except when the slope is either negative or positive. Okay? Hopefully that makes sense. Okay. So what does this correlation tell you? Well, it tells you about the strength of the relationship between those two variables, right? If you have a very high positive correlation, it means that, okay, there's a very good chance that those two variables move together, that those two variables have a positive relationship, okay? Whereas if you have a very strong negative correlation, okay, say you have a correlation close to -1 or negative 0.9 or something like that, then that would show that those two variables have a very strong negative or opposite relationship to each other. Yeah? Okay, so we're going to talk about one more concept having to do with all of this stuff, and then I'll let you guys work on your homework.